It was a busy third quarter for NASA's Exploration Systems Division. The first liquid hydrogen tank barrel segment for the core stage of America's new Deep Space Launch Vehicle was recently completed at the Vertical Weld Center at NASA's Michoud Assembly Facility in New Orleans. The segment is considered a confidence barrel segment because it validates that the Vertical Weld Center is working the way it should. When all segments are complete, the 212-foot core stage will be assembled in the Vertical Assembly Center, now under construction. In August, a 31-inch scale model of the SLS Core Stage B2 test stand was successfully tested in a wind tunnel. The actual B2 test stand, located at NASA's Stennis Space Center in Mississippi, was originally built to test Saturn rocket stages. The stand is being renovated to enable testing of the SLS core stage. The core stage with 4 RS-25 rocket engines will be installed on the B2 stand for propellant fill and drain testing and 2 hot fire tests in late 2016 and early 2017. In August, the largest 3D printed rocket engine component ever built by NASA, an injector, was tested during an engine firing that generated a record 20,000 pounds of thrust. 3D printed parts have the potential to drastically reduce the time and cost of producing future flight engine components. In September, the Orion stage adapter diaphragm arrived at the Marshall Space Flight Center to undergo pressurized testing before being integrated with the spacecraft's stage adapter, certifying it for flight conditions. The component is an integral part of the stage adapter that will connect Orion to a Delta IV Heavy rocket for NASA's Exploration Flight Test 1 in 2014. The diaphragm, a lightweight composite structure, serves as a barrier between the upper stage of the launch vehicle and the spacecraft, preventing hydrogen gas buildup from the rocket beneath the spacecraft before and during launch. At the Kennedy Space Center in Florida, one of the launch pads at Launch Complex 39 is undergoing extensive upgrades to support the agency's 21st century space launch objectives. A new universal flame deflector and trench will be completed in early 2015 and will support the new Space Launch System rocket and possibly a variety of commercial launch vehicles. For more than a year, NASA's Crawler Transporter, CT-2, has been undergoing a major tune-up in KSC's Vehicle Assembly Building. The crawler modifications are designed to enable the vehicle to transport heavier launch vehicles, including SLS, to the pad. Once the roller bearing work on half the crawler is completed, it will be prepared for a test rollout scheduled for January 2014. After traveling 3,600 miles above the Earth during the Exploration Flight Test 1 mission in September 2014, Orion will splash down in the Pacific Ocean, where it will be recovered with the help of the United States Navy. In August, with the Navy's USS Arlington stationed against its pier in Virginia, divers in small boats led the test capsule to the flooded well deck of the ship. With the capsule in position over the recovery cradle, the water drained until the capsule settled. Navy divers prepared for the recovery test in Norfolk by training in the 6.2 million-gallon pool at NASA's Neutral Buoyancy Lab near the Johnson Space Center in Houston. In July, the Orion team successfully conducted the Parachute Test Vehicle PTV-5 airdrop test at the U.S. Army's Yuma Proving Ground. 17 parachutes were deployed during this test. 9 were test technique related and 8 were the Orion system parachutes. At the Operations and Checkout Building High Bay at the Kennedy Space Center, the Orion team completed hundreds of welds and installations for the spacecraft's propulsion, life support, and environmental control systems. At the Johnson Space Center in Houston, NASA Administrator Charles Bolden welcomed 8 new astronaut candidates. This group will be among those who may carry out the first ever human missions to an asteroid and onto Mars. In October, recorded Orion telemetry was successfully transmitted between the Mission Control Center in Houston and the White Sands Communication Facility in New Mexico. White Sands will be used during the EFT-1 flight to receive and retransmit the Orion spacecraft telemetry. In late September, NASA astronauts Rick Linehan and Mike Foreman tried out a prototype display and control system inside an Orion spacecraft mock-up at Johnson Space Center during an Orion ascent simulation. Over the course of 2 weeks, 10 crews of 2 astronauts each performed launch and abort simulations inside the Orion mock-up to fine-tune the design of the displays and controls.